Hello, everyone, and welcome to today's webinar, Training Your LLM Dragons, Why DSPM is Foundational for Every AI Initiative. Before we get started, I would like to go over a few items so you know how to participate in today's event. You will have the opportunity to submit text questions to today's presenters by typing in your questions into the questions pane of the control panel. You may send in your questions at any time during the presentation. We will collect them and contact you after the webinar to respond. If you would like to download more information pertaining to this topic, you can do so via the control panel at any time during the session. Today's webinar is being recorded, and you will receive a follow-up email within 24 to 48 hours with a link to view the recording. I would now like to introduce you to our presenters for today, Parag Bajaria, VP of Product Management, and Vamsi Kuduru, Director of Product Management for Normalize. Gentlemen, over to you.
Thanks, Stacey.
Thank you, Stacey. Hey, everybody. Thank you for joining us today. And we want to kick off things by addressing one key question, right? Which is AI a data security compliance issue, right? And the answer to that is yes, but it's not just a theoretical risk, and it's happening right now. And let's take a look at why that is.
Yeah, Parag, that's an interesting point, right? Because I think AI has become kind of a growing concern for a lot of businesses, especially with how much sensitive information is being handled and managed by these systems. And this is kind of basically turning these into prime targets for attackers, because a lot of businesses, with how young this whole thing is from widespread adoption, there's not enough security in place. So it's very easy to get access to a lot of this sensitive information by taking advantage of vulnerable AI models. So I think the general trend that we're seeing is that attackers are viewing this as a more and more lucrative target. And because of how complex these systems are, the overall cost to kind of mitigate and remediate some of these issues that arise is becoming a lot more expensive and difficult to do. So really kind of the main thing we're seeing is that businesses have to be a little more proactive in managing these breaches and kind of mitigating some of the things that are leading to them, if you will.
And look, Vamsi, it's not just the hackers and because of that problems exist, right? AI can also lead to accidental data leakages, right? It's not always the hacker that does things. Think about training data, right? I mean, many of these models use training data, and if the sensitive data is somehow embedded through this training data, then it can pop up on response. And we've seen that, right? There's lots of news around something proprietary within a company. It's not supposed to be revealed, but somehow something got in to the training data, and then it caused exposure, right? I mean, just imagine a simple scenario, right? Let's say that you're training a customer service chatbot, right? And to do that, a lot of times you would just end up training on real support tickets. And what if some of those support tickets had details like credit card information? Now that credit card information is embedded into the model itself, right? So it's not always malicious intent that lead to data exposure, right? But regardless of how things get in, right? I mean, the consequences are still pretty serious, right?
No, that's a good point, Parag. And I think there was a pretty high profile case, I think last year or pretty recently, where you had a large enterprise which had their employees just harmlessly kind of uploading some source code or some information for validation before they push it into prod. And now these were all proprietary knowledge that was now made available to their whole competition without any deliberate intent. This kind of highlights some of the underlying quirks or potential for just accidental leakage that these models have, even if they're very well developed and secured system, just by the nature of how these work. And I think Gartner reports are showing that pretty soon more than half or about half of businesses will have experienced some sort of AI attack, whether deliberate or not, over the globally, which is quite a large number. And I think this kind of highlights why this is such a big target in general. Is that, look, the amount of data that's being fed into these models is not only large, but it's also highly critical, highly sensitive information that if someone gets access to, they're going to be able to either do a lot of good, do a lot of harm, what have you. But these are all critical business assets. And the only way for these organizations to take advantage of the AI and the power it gives is making sure there's proactive security in place to first understand what's going into it. And can I catch these things before it's too late?
Yeah, and let's not forget the regulatory aspect of this, right? I mean, regulations like GDPR, CCPA, HIPAA, PCI, etc., are all looking very closely at how AI uses sensitive data, personal data. And as we very well know, right, non-compliance can be pretty costly, like in case of GDPR, right, 4% of your annual turnover. So this isn't something that simply you can afford to ignore. Imagine your AI system inadvertently exposing PII data without or personal health information without explicit consent. Right? Not only can this lead to financial penalties, but also damage your brand's trust and reputation. Right? So compliance is just not a checkbox. It's about making sure that your integrity of your business and maintaining trust of your users.
And I think that trust is the thing I want to double click on a little bit is, one of the main questions that me as a consumer myself, if I'm giving my information to a business, I want to understand how are they using it? Am I going to be exposed to additional risks if I present this information to a business? And KPMG is kind of, their studies show that over 95% of business leaders also kind of align with this thought is, hey, how do I ensure that I'm using this properly and can build that trust and maintain that integrity with my customers, right? Because once you've lost it, it's hard to regain. And I think that's kind of the balance people have to kind of wrestle around today is how do we ensure that none of the sensitive customer information is going to be mishandled or misused by AI models? And how do we be transparent about at least educating ourselves, but also educating our customers? This is how we're going to use your data. This is why it's safe. You can be sure, right? That level of certainty needs to be established. And this is a journey that we're all going to have to kind of go on together to figure out what's that right process going to look like and how do we secure these models and actually promote innovation.
Couldn't agree more, Wamsi. And to that end, I mean, and we've done enough talking, right? Let's see what do we see in the real world, right? So, what I'm showing here is a OSWAP, which has come out with a list of the top 10 exploits for LLM, right? And this reflects what they have seen in real world, right? This is not theoretical exploits, what have been observed. Now, there's a lot of information on this slide, and I'm not going to cover all of it because I think you can go to their website and see a lot of details about it. For today, I want to keep things simple and focus on 3 of these threats that have direct connection to sensitive data disclosure, right? So let's jump in, right? So the first one is prompt injection. What does that mean, right? It is when attacker cleverly crafts their input to make the model do something that it shouldn't. It is like a bit like a SQL injection, if you're familiar with that, right? It is like, how do I find a loophole? So instead of asking the AI model direct information, right, the attacker uses sneaky way. So let's take an example. Okay, let's say that we have an employee named Sheila, and the attacker wants to get their birth date. So instead of asking directly that what is the birth date of Sheila, which nowadays most of these models know how to block it off. The attacker could say that, hey, by the way, we are planning a birthday party for Sheila, and could you set up a calendar invite for Sheila's birthday to remind me? Now, see what happened here, right? The model interprets this as an innocent request, right, and ends up scheduling a calendar invite. But what happened here is that the model revealed Sheila's birthday, right, without even realizing it. So the attacker took advantage of model's good intention, per se, right? So that's one aspect of prompt injection.
And I think that's an interesting point there, Parag, is a lot of these models are really relying on the context that you're providing. And it's very easy to kind of manipulate what's considered positive or negative context, or even in some cases, it might not be codified in as something that's accessing sensitive information, right? It's almost like a piecemeal approach. You might ask for, highly critical information all at once and it won't give it to you, but you can do targeted requests to get one piece, and another. And all of a sudden you've now pieced together the same thing the model initially told you was sensitive, right? And this is something that's going to be a growing problem. And I think there's a whole industry that's forming out of this, right? It's prompt engineering. So,
and actually later on, I'm hoping we can demo some of this, right? That how easy it is to do some of these workarounds, right?
yeah, I think I'll definitely, go into that when we get into the Copilot portions, but it's super interesting. For sure.
Yeah. And the next one is training data poisoning, right? This is a bit different. Here, the idea is to mess around with actually the data that's used for training the LLM. So if a tracker can get to the sensitive data in the training set, then they can change how the model behaves, right? Um, and sometimes you don't even need direct access to the model. If you know how the models are being trained, then you can do even more clever workarounds, right? For instance, right, somebody, let's say that you say, hey, model, can you help me remember all my friends' birthday? And start listing birthdays of everybody. Now, that might seem innocent, but if the model is retaining that information and it is using that information to do training for its next round, right? Then this data sticks around, right? So if next time somebody asks casually for Sheila's birthday, let's say that was one of your friend, right? The model can end up giving it out despite it never being in the original data set, right? So it's a bit sneaky in that sense, which is why it's absolutely critical that you manage what is going into the training data, not just the first set, but also when you're retraining.
And this has been a problem, I think, even before LLMs became so widespread, right? We saw this with some of initially started popping up when we looked at some of the legal recommendation algorithms that were in place for sentence recommendations. It's ended up over time building a prejudice based off of the people that were going in due to all the different metrics and stats about the individuals and their past sentences. So over time, a prejudice developed, right? Same thing is going to happen with these training data sets for LLMs. If you're using the wrong context or very narrow focus context, or people are even intentionally putting things which have specific, ideologies or specific things in place, that's where some of those ethical dilemmas or incorrect responses start getting generated, right? Because it's all dependent on how you've trained these models. So I think there's a lot of responsibility both in the people creating these models, but also the people that are interacting with it day to day and giving it that context that it needs.
Yeah, couldn't agree more, right? And ultimately, what happens is that sensitive data gets disclosed, right? This is the other hack, right? This is when the LLM is accidentally giving out private data in its response. And sometimes this happens because there was not enough care done in scrubbing the training data, or the model was not set up properly with the right boundaries to handle sensitive inputs, right? Let's say, for example, a data scientist is training a model to improve their customer service. They pull some client data and forget to mask the credit card details. Now, because of that oversight, the credit card information got mixed up into models training. This means theoretically that sensitive data could be retrieved using any of these prompt techniques, right? So even though that was not the original intent, right, but because it was done by mistake, right, things came in. It's a reminder, right, how crucial data sanitization is for these models.
100%. And I think some of this too ties into the earlier points. Is there could be, let's just take a document, for example. The document might have a lot of sensitive information, but it might have one piece in there which the model doesn't deem as sensitive, and you ask it for that exact thing. It will then point you to the sensitive document, which you can then potentially even have, summarized, or might give you additional information about what it shouldn't have shown, right? There's a lot of this gray area here where you can kind of subvert some of the built-in controls and governance around these. And that's kind of where you need some additional tool or some additional oversight to kind of help you identify, are these outputs, are they sensitive? Are they not? Who's generating it? Are there any potential gaps even, right?
Mhm.
And really try to lock it down and have additional layers before it's exposed and gets widely distributed, if you will.
Very much so. So let's explore how does sensitive data get into this LLMs, right? And there are two main ways that this can happen. One is when you're doing your own custom model training, and other is when you're using services like Copilot or Gemini, right? So we'll first walk through the custom model scenario in detail, and then I'll cover the use case. Then we'll cover the use case of services like Copilot, right? So what we are seeing in this slide here is a visual representation of how sensitive data flows into LLM, right? So if we take a look in the top section, right, we are seeing that there's a data scientist who is working on training data, very typical. Right? This data store is pulled from a data store which contains sensitive information, or right, and the data is then used for fine tuning a foundational model, eventually creating a custom model, right? So the risk here, as you can see, is that the training data is not properly sanitized, as in the sensitive information uh, uh, it was not removed, right? Which means, as we were talking earlier, this is how potentially the sensitive data can get into the custom model, right? Now, at the bottom, we see that another way of how sensitive data gets in, which is that we see a user interacting with the model, and the user provides a prompt along with documents, which are then processed by the applications. These documents are converted, usually, sorry for being a little technical here, but in a vector format, uploaded in a RAG database. And if this document that user uploads consists sensitive information, then there is a risk that this information can be then embedded in responses generated by the custom model, especially if it's stored or retained inappropriately, right? If it's used for doing more training. So this is where the data flow management becomes crucial to ensure that no unintended sensitive data makes into training or the output of the responses, right? So the key takeaway is, right, that sensitive data can enter at multiple points during training, during data ingestion, during user interaction, and ensuring that proper sanitization happens, limiting retention, employing security checks at each stage is essential to prevent sensitive information from inadvertently embedded or exposed, right? And let me actually show you a brief demo, right, of how can you identify this information of sensitive data getting fed into your custom model, right? It's super easy to do that, and I'll briefly cover in the demo how do we do that. So with that, I'm going to share my screen. All right, let's jump into the demo. I've shared my screen, and what you see on the screen is the data stores page of the UI. Here you can see all the data stores that we've discovered. When you configure the cloud connectors, normalized automatically discovers all the data stores, both structured and unstructured, in your cloud accounts, in your SaaS applications, and on-prem, and it scans it for sensitive data, as you can see here. And as part of this cloud scan, Normalize also discovers all the data stores that are connected to various AI services, and to see which does any of these AI data stores are connected to any of the AI services. All you do is click and select any of these, and you can see that it has filtered this view. Now, let's do a quick check-in. So this GCP bucket has some sensitive data. So let's click into that, right? In the overview section, you can see that there are multiple entity types in this. There's PII information, as well as GDPR information, and even some intellectual property like recipe. All right. So this kind of gives you a quick overview of what type of sensitive data is in this data store. Now we are interested in what's happening with AI, right? So let's switch over to the GCP Vertex AI. Here you can see that there are actually multiple data sets, right, which are the primary units, how the GCP AI services consume data, right? And they are all linked to this particular GCP bucket. Not only that, you can see that some of these data sets are actually connected to the AI training pipeline, which means that they are already being used in generating custom models. And for one of this, right, there is actually a custom model that has been trained on this, right? So as you can see, right, that we are not only identified the sensitive data, which is located in the GCP bucket, what kind it is, but we have also shown how the data is flowing, right? How it's connected to data set, the training pipeline, and the custom model, right? We are seeing the whole lineage, complete lineage, right, from origin to the use. And this is incredibly useful for maintaining both compliance and security, right? So in this scenario, right, we are giving you complete information of your sensitive data. Not only that, right, we also proactively notify you if there is a custom model that is consuming your sensitive data. So let's go over to the risks screen, and we will look for Vertex. And what you're seeing here is that we will generate this risk if the Vertex dataset is consuming any sort of sensitive data, if it's linked to any kind of sensitive data store, right? As you can see, you can click into this risk. It'll show you which data set is linked to this, and then you can go to the data set and see what it is, which data store is this data set linked into, right? So we cover end to end, right? Not only do we identify the lineage, but if there is new sensitive data as in it was cleaned before, and we kind of discover that sensitive data landed later, will alert you right then and there. So let's now summarize, right? What are the things that we can do to mitigate sensitive data exposure? And to that end, I'm going to go back to the slides. So there are 4 or 5 main places where I would suggest focusing, right? One is, as we extensively talked about, maintaining, monitoring your training data and RAG data, right? Regularly audit and review your training data sources. It's important to scan this data for sensitive information before it's used. By doing that, right, you reduce any chance of sensitive data inadvertently making it to your model, right? So this is a must-have. Second thing, as I showed you, is that tracking the lineage of training data, right? Keeping detailed records of where your training data comes from, how it's used, right? Basically, you want to be able to trace the entire lineage of your data, right? From initial data set to where the model is deployed, which application, how it's being interacted, etc. This is crucial for compliance, and not only that, but for your trust and accountability, right? The third thing is, as we talked about various in the LLM challenges or exploits, right? That inputs and outputs, right? So it is very important that you monitor what inputs are going into your model, right? Which means setting up logging, monitoring, right? And not only just for inputs, but also for the outputs. This way, you can identify any sensitive data being introduced through not training data, but through inputs and outputs of the model per se, right? And fourth thing is that you got to make sure that your data, sensitive data, is either removed or anonymized, right? I mean, there are many different techniques to do data anonymization, right? Masking, encrypting, transforming data in a way that it's not directly identifiable, right? So that way, anonymization adds an extra layer of protection. So even if the data leaks, right, it won't have a direct impact on an individual's privacy. And finally, right, and again, very important, we haven't talked that much about it, but it is important that you restrict access to sensitive data to who really need it, right?
Yeah,
Proper
absolutely.
access controls are fundamental, all right, to keeping your data AI system secure. So making sure that data scientists, engineers, whoever else is handling data, have only permissions they need and nothing more, right? This limits the risk of accidental exposure or misuse. So yeah, I mean, this is some of the steps that you can take to mitigate the risk. So I'm going to wrap up here, and I'm going to hand things over to Vamsi, who will talk about sensitive data flow into services like Copilot and Gemini. So over to you, Vamsi.
Yeah, thanks, Parag. So so for this example, I'm going to be discussing how sensitive data is flowing through something like a Copilot. Now, you can really think of this as having 6 main steps. Step 1 is a user prompt, right? So when a user submits a prompt, in this case through something like a Word, Teams, Excel, or even directly through Copilot, this is what initiates the whole process, which would then trigger the Copilot flow. Once this flow is triggered, you then have the pre-processing phase, which is where the Microsoft Graph and the semantic index is taking all the organizational context from all your different applications, think emails, files, chats, contacts, etc., and then using that to pre-process the prompt, which you would then send back to the LLM model to then do the actual task that was asked of it. This is kind of what makes sure that the information that's being presented is highly relevant to the prompt and ensures that it's answering what you asked for. Once it's in the LLM, this is where it's doing all of the actual analysis of the customer data, of the information that's fed into it to then generate whether it's a summary in your ultimate output, right? So this is all tailored based off of the step 1 piece, which is the prompt, which is tying back to what we mentioned earlier, why prompt engineering and all that is super critical for this whole process and how we can manipulate the outputs, if you will. Once the LLM response has been made, this is then integrated further into your organizational context, and then this is what allows you to then consume it in your final response, whether it's in your apps or what have you in step 6. Now, as you can imagine, in all 6 of these steps, there's some inherent risks or basically around data security that I think they're worth calling out. On the prompt side of things, because users are interacting directly from your application, there's always an inherent risk of there being some unauthorized access of data, especially when there's not proper role-based access controls that are in place or even being enforced. And on the pre-processing side, because the Copilot itself is taking advantage of the graph and semantic index that Microsoft has, you need to ensure that you have the appropriate sensitivity labels, which in the case of Microsoft is going to be MIP labels, to ensure that it's not leveraging any of the data as part of its RAG that a user should not see, or it's not pulling context from documents that a user should not see as part of this process. Right? So it's kind of one thing to ensure kind of they go hand in hand is there's a lot of controls in place that Copilot offers, but it still requires the business to be kind of attuned and making sure they do have some of these implemented so that these models themselves can take advantage of it in determining what should be shown and not. And tying back into some of the data leakage concerns we spoke about earlier, if there's any data that's being retained or even sometimes multiple documents together forming context that it shouldn't, there's always a chance that the prompt might reveal information that it originally would not have or things it might not even deem as sensitive, right? This kind of ties into that unintentional data leak that we talked about earlier, where over time you can just have models transform and start outputting information that they shouldn't. And this naturally ties into the sensitive output sides of things, right? Because we don't always have the right context and there's always a sequence of questions that can happen, Copilot could, for instance, generate or an output that has a lot of confidential data based off of what is pulled in. And this is kind of why it's important to really monitor the outputs of these models so you at least understand when this information is being exposed to your customers so that you can kind of mitigate some of this risk that's tied to the post-processing side of it. And ultimately, all of this ties into the potential data overexposure, right? Because of how widespread Copilot's going to be throughout all your organization's apps and services, you just want to always ensure that only the right users have access to the right documents and you properly index and put as many controls as you can to really kind of help lock this down, right? So these are just some of the risks that are going to be associated with it. Now, let me show you a simple demo walking you through a simple example highlighting some of these challenges and risks that we spoke about. In this demo, I'm going to quickly show you how easy it is to generate a prompt in Copilot to get access to some sensitive information that a user otherwise wouldn't. So in this case, let me ask a simple question such as, is anyone getting laid off? As this kind of works through, you'll notice here that it says, even though it couldn't find anything recently discussing layoffs, it did find me and reveal a bunch of files, which, looking at the name of these, you can kind of determine is probably some sensitive information. One thing I want to highlight here, though, is you'll notice that Copilot is checking for sensitivity labels that are applied on these files. Now, obviously, I'm an admin on this account, so I'm able to see these. But this kind of highlights why it's important to ensure you have proper controls in place. Now, let me ask a more specific question. Now, this is obviously some synthetic data that we generated for the sake of this demo, but let me ask a very targeted question here. Is a specific person and you'll notice I can even target and get information about a specific user. When is he getting laid off? Right, all of this is something that the Copilot itself is revealing for me. Now, imagine if I didn't have some of these labels and stuff in place on this document, maybe someone had accidentally put an org-wide share. Anyone in the organization would have been able to follow the same sequence to get this information that I just kind of walked you guys through. Now, let me show you an example of what Normalize can do to help you kind of identify the sensitive information as we're classifying it and directly apply it in the context of your Microsoft suite. So Normalize offers the ability to map MIP labels to sensitive content that we're discovering. So you'll notice here in this example for several different data classes that we have here, we are able to sync and map from existing MIP labels that are present in a user account so that whenever we identify any of this information, we can ensure that the appropriate labels and access controls are being enforced. Now, this acts as a good secondary measure to secure your data because you have now a second solution that's classifying and finding all your sensitive information. And now through this, you can also directly govern some of the access controls on it. Now, keep in mind that in order for MIP labels to be an effective solution for mitigating data that's exposed to Copilot, you have to configure the right access controls and groups in your compliance hub as part of your Azure portal. So just keep that in mind that in order for MIP labels to really do what they're meant to here for Copilot, you still need to ensure that you put the right groups or users assigned to each access group, right? So it's not just going to magically identify which user should or should not see something, but it gives you additional layers of security and really protecting your sensitive assets within Copilot. Now, this obviously was a very simple use case project, just kind of trying to highlight how easy it is to generate prompts that reveal sensitive information. Now, you can easily extrapolate for users that don't have admin privileges. If these controls weren't in place, the level of sensitive information that can be easily accessed, right? And I think we've seen this with some customers as well as they're kind of going through their initial onboarding journey of Copilot was really trying to mitigate some of these risks as they rolled it out to users, because the larger your organization is and the wider spread these apps are, it's harder and harder to understand all the different data contexts and things that are being fed in. So this kind of acts as an additional layer there for individuals, kind of get that additional comfort, if you will. So now so how do we help secure this? What are some recommendations you can follow to kind of really adopt Copilot without having as much concern or ensuring it's as secure as it can be? So the first step is obviously going to be, as I mentioned, taking advantage of MIP labels to govern access. Now, one of the beautiful things about Copilot and other similar applications is that they do their best to look at the different access controls that are on these documents or applications, right? This includes direct access that's given on a file, things like org-wide links, organizational policies, also MIP labels as that sensitivity labels, if you will, is at a final level of governance where you can really restrict who should see what. So this is why it's super important to make sure you've taken advantage of all these different security measures that these apps offer out of box, because Copilot is leveraging it, and this is really the easiest way to really ensure there's not as accidental data leakage, right, if you will. Second most important part is really classifying all your content, or more importantly, just understanding all of the data that's present in your environment before you roll out a Copilot. Because once you start indexing everything and feeding it into an application like this or Gemini or things of that nature, and you don't have full visibility into your own data environment, you're not really going to be able to ensure that there's not accidental leakages or that you have the proper governance and controls in place on all that sensitive information that's sitting there. So this is, I think, should be step one, is kind of the whole scale assessment of what data do we have, how secure is it, and is least permissive access, and really being enforced across the board. And to better understand how Copilot is taking advantage of all the context information you're feeding into it, it's really important to also classify the output. That way you identify if there's any changes or deviations where now all of a sudden it's starting to display sensitive information back to a user that otherwise it should not have been or was not in the past, right? So kind of this is more of that proactive approaches. It might be fine on day zero, but you need to constantly be monitoring to make sure that over time things aren't being fed into the model, or governance is kind of waning, or access controls are waning, if you will, and more information is now being exposed. And finally, there's a more manual way you can kind of limit the scope of what Copilot uses, and that's by using a curated list of allowed SharePoint sites. So you can only, in this approach, you're basically sanitizing, let's, for example, a bunch of SharePoint sites, let's say up to 100 for sake of conversation, which your team has vetted and understood that, hey, this is information that's all okay to go into an LLM like Copilot. And these are the only ones that you index and enable as part of the restricted search capabilities that Copilot offers, right? This is kind of more of the, hey, I don't want to take any risks. I'm just going to put all my sanitized information in one place, and then I don't have to worry about rolling it out across all my different applications or SharePoint sites. And so kind of, I think the best choice here is pick what makes the most sense for your organization based off of where you are and then in your Copilot adoption maturity. But just know that there's a lot of different options that you have to mitigate the risk. But ultimately, this is a journey, right? You have to be constantly proactive in monitoring how this application is performing, and other similar LLM models like this as well, right? To really ensure that your business is secure and there's none of these challenges that we talked about so far today. So kind of wrap up here, appreciate everyone listening to a webinar. If you'd like to learn more about what Normalize is doing, please download the Gartner Cool Vendor Report, as well as download some of the content materials that we've attached to this webinar. And we appreciate your time.
Thank you.